All right, good morning and happy Thursday. We're going to hop right into the lesson, try to make this one short and sweet. Today, you're going to be using visual models. So remember, those are things like tape diagrams, number lines, to add two fractions together. And we're going to look at denominators such as 2, 3, 4, 5, 6, 8, 10, and 12. Okay, so we've been doing this. We're just really getting some more practice and taking it next level. And I hope you guys are really starting to feel thumbs up about this. So let's go ahead and get started. Let's look at 3/8 and 3/4. And remember, yesterday I kept talking about apples or bananas and oranges, or apples and oranges. We can't add those, right? Just like we can't add 8ths and 4ths right now. Why? Well, because we need to have that common denominator. So, am I going to change my 8ths or my 4ths? Let's go ahead and rename our 4ths. And let's use a tape diagram. So that's going to be the visual model we use for this one. So 3/8 plus 3/4. Hopefully you have your whiteboard or your math journal. And if I'm going to draw 4ths, I know that I would need 4 boxes, and 3/4, 3 would be shaded, right? Now, if I want to make my 4ths into 8ths, what would I have to do? Well, I would have to divide or decompose each one of these pieces in half. And now if I count, I've got 2, 4, 6, 8 total pieces. And how many 8ths do I have? I have 2, 4, 6, 8. So I know that 3/4 is equivalent to 6/8. Now I can add my 3/8 and my 6/8 because they do have the like denominators. 6 plus 3 is 9. And my denominator stays the same. So on some of the work, I've been seeing some people adding the denominators. Remember, when we're adding or subtracting fractions, we find that common unit because the denominator stays the same. Okay, so I have 9/8. Can I stop here? And hopefully you're saying no. I know that this is an improper fraction, right? I have to make it a mixed number. And we do that with our number bond. So I know I have 8/8, which is 1 whole. And then to get to my 9/8, I have 1 more 8. So this would actually be 1 and 1/8. So 3/8 plus 3/4, or 3/8 plus 6/8 equals 1 and 1/8. Very good. Now let's look at another one. And this time we're going to solve and look at it on a number line. So I have 1/2 and 7/8. And I like to go ahead and change my denominator first because that helps me know if my sum is I can estimate and think, well, is my sum probably going to be greater than 1 or less than 1? And I know how I can set up my tape diagram or my number line. I'm sorry. So 1/2 and 7/8. 1/2 plus 7/8. Right now I've got oranges and bananas, right? I have to make them the same. So I have to make my halves into 8s, okay? I know that to get to 8, I would have to multiply my denominator by 4, okay? And so my numerator is going to be 4, and I'm estimating that it's probably going to be greater than 1. So I'm going to go ahead and draw my number line here. And I'm going to make my benchmarks 0 and 2 with 1 in the middle. And I start with halves, right? So I've got 0 halves, and then 1 whole in halves would be 2 halves, right? And then 2 times 2 wholes would be 4 halves, right? Because 2 times 2 is 4. Okay. So I've got 0, 1, 2, 3, 4. So I've got 1/2 here. Then I've got 3/2 here. Now, if I want to change this to 8ths, I know that my benchmark for 0 is obviously going to be 0/8. And I could change colors to make it easier to see. I know that 1 whole in 8ths is 8/8. And then I know 8 times 2 is 16. So 2 wholes is going to be 16/8. Okay. So those are my benchmarks in 8ths. I know 1/2 of 8 is going to be 4/8. Okay. And then halfway between 8 and 16, well, I'm going to add 4 to 8, and I'm going to get 12/8, right? Okay. So now I can go back in and add all my other, I have 1/8, 2/8, 3/8. There's my 4, 5, 6, 7. So I would have to, instead of having 2 pieces, I need to have 4 pieces in each one to make it 8ths, okay? Because 2 times 4 equals 8. If I'm multiplying the bottom by 4, I have to multiply the top by 4. So 1 times 4 is 4. So 1/2 is equivalent to 4/8, and I can actually see that here on my number line, right? If I wanted to add 7 more 8ths, I would simply jump 1, 2, 3, 4, 5, 6, 7, and I'm going to land right here, which is at 11/8, okay? Now, let's check it by doing our addition up here. I said 1/2, you can see, is equivalent to 4/8. So now I have 8ths plus 8ths, right? I have 4/8 plus 7/8, and 7 plus 4 is 11/8. So I'm proving it with my number line and solving. Now, look at 11/8. Can I stop here? And hopefully you're saying no, of course you can't, because 11/8 is an improper fraction. So I need to draw my number bond, right? I'm going to have to do a sideways number bond. 1 whole in 8ths would be 8/8. And then I would need 3 more 8ths to get to 11. So my answer is actually 1 whole in 3/8. Okay? Very good. Let's see. Last thing we're going to do is we're not going to use any models at all. This is my preferred method or strategy for you. I love to be able to show it with a tape diagram or a number line, and if that helps you, yes, do that. But I want you to be able to just use multiplication to get your common denominators, okay? So for instance, let's take 3/4 and 6/8. Which unit are we going to rename? Well, we're going to rename our fourths and make it 8ths, right? And we're going to use multiplication to do that. So let's go to our fresh board and write 3/4 plus 6/8. So I've got my 3/4 plus my 6/8. I want to rename fourths to 8ths. So what do I have to multiply? 4 times what gives me 8? And hopefully you are able to recognize that 4 times 2 is 8. We know anything we do to the denominator, we have to do to the numerator. So if I'm doing times 2 at the bottom, I'm going to do times 2 on top, okay? So now I have 6/8. So now I have 6/8 plus 6/8. I no longer have apples and oranges. I have all oranges or all apples. 6/8 plus 6/8 is going to give me 12/8. Can I stop here? And hopefully you're getting that eye and you're saying, no, Miss Johnson, the numerator is larger than the denominator, and I know that's an improper fraction. I'm going to use my number bond. 1 whole in 8ths is 8. And then if I count up, 9, 10, 11, 12, I have 4 more 8ths. So my mixed number would be 1 whole and 4 8ths. Now, I would accept 1 and 4/8. But when I look at 4/8, my mind says, Miss Johnson, that can go even lower. I can change 4/8 to 1 and 1 and 1 because 4/8 is a half, right? So my final answer would be 1 1/2. I want to practice one more of these, okay? And then we'll kind of move on to the problem set next to ticket. So let's try 2/5 and 7/10, doing the same exact thing. So I have 2/5 plus 7/10. There's those apples and oranges again. I need them to be the same. I can make fifths, tenths, right? What would I need to multiply by? And hopefully you know that 5 times 2 gives you 10, right? Anything I do to the denominator, we know I have to also do to the numerator. So now I have tenths on the bottom, 2 times 5, and 2 times 2 is 4. So now I have 4/10 plus 7/10. And I can add these because they have like units. And now I have 11/10 because 7 plus 4 is 11. Can I stop here? And hopefully you're used to saying, well, no, Miss Johnson, you can't. Got my number bond. I've got my improper fraction. A whole in tenths is 10/10. I need one more tenth to get to 11/10. 1 1/10 would be my final answer. Okay. So hopefully after today's lesson, we've been doing this, but hopefully this just really hammers it home for you. I want you guys to go ahead and take a look at your problem set really quickly. So it's going to be obviously green because today is Thursday. Anything in green you will do today. So let's take a look. Number 1, draw a tape diagram to represent each add-in, decompose the tape diagram to make like units, and then write a complete number sentence. Use a number bond to write the sum as a mixed number. It's what we just did in the lesson. You're going to draw a tape diagram. You're going to show me how 1/4 becomes, or 1/2 becomes fourths, because we have to get it to be fourths to add right here. Excuse me. Then you're going to write your new number sentence. So 3/4 plus however many fourths equals however many fourths, okay? And then if it's an improper fraction, you have to make it a mixed number. So what we just did together, you're going to do that for all of number 1. For number 2, you're doing the same exact thing, except this time I want to challenge you to use a number line. If you have trouble with the number line, really just I want you to focus on making like denominators and doing the addition. Number 3, you have the ability to use a model if you want, but you don't have to, so you could just use multiplication to find your like denominator. It says draw a model if needed, and don't forget to use a number bond to find that mixed number. Okay, easy peasy. So that's all it is on the problem set. And then let's take a look at the exit ticket together real quick so you're aware of your expectation on that. Let's see here. So for the exit ticket, solve. Write a complete number sentence. Make sure that you use a number bond to write the sum as a mixed number. Use a model if needed. So you don't have to do any models here. You have 2 problems. The first one is 1/4 plus 7/8. So you have to get your apples and oranges to be all apples, okay? Or all oranges. And then same with 2/3 and 7/12. Don't forget at the end to write a mixed number. Okay, I know you guys are going to do great. Today's code word, there was not a code word on Tuesday, and many of you noticed that, but today's code word is actually going to be, what could it be today? Today's code word is going to be s'mores. And I'm picking that code word because we have our camp out party coming up very soon for those of you who have kept up with all of your work. So today's code word is s'mores. I hope y'all have an awesome day, and I look forward to chatting with everybody soon.